In June 2016, a CBS News poll asked, "Do you think it should be legal or not for same-sex couples to marry?" The sample size was 1,280 adults in the United States. 58% of the individuals in the sample responded legal. Is this evidence at the 5% level of significance that a majority, more than 50% of adults in the United States think same-sex marriage should be legal? Use the Z-test for one sample portions worksheet to work out the entire hypothesis test. All right, so first of all, I have the worksheet right here. It is. It's right here. There's a link to this worksheet on the question. This goes through all the details step by step for doing a hypothesis test. First, before I get started going through the steps, let's just write down the basic information for reference. We have sample size, 1,280 adults, so that's n equals 1,280. I'll just write this up on top here. N is 1,280. All right, p hat, it said 58%. So p hat is 0.58. That way I don't have to keep going back to reference those. And the question was, is this evidence that a majority of adults think same-sex marriage should be legal? So let's go to the hypothesis. So step one, the null and alternate hypothesis. So the null is always something equals something. In this case, p equals 0.50. The p sub 0 is, let's write that down as well, because we want to know if something is a majority, so the alternate will be more than 0.50, and then the null is just 0.50. And so the alternate, oh, I forgot to write HO here. Okay, the alternate, HA, is that P is more than 50%, implying a majority. Okay, now, without going through all the calculations, let's have a rough estimate here. P hat is 58%. The null hypothesis says 50, so that's 8 percentage points higher. Out of a sample over 1,000 people in the sample, that's going to be a pretty small margin of error. So I would have to say that yes, we have some pretty good evidence that the real percentage really is more than 50%. It's probably in the upper 50s. All right, so let's keep going. Step two, obtain a sample and collect the data. Okay, we got our sample, we got our data result. It's 0.58 is the p hat right there. Now, is the sample random? Let's check the conditions. Is the sample random? Well, we don't know for sure. Let's go back to the question. A lot of times in the question, it'll actually say in the question that there was a random sample. It just says a CBS News poll. Now, if it's some kind of Insta poll where people click something online to express their opinions, then no, that's a volunteer sample, and that would not be random. But let's click this link here. There's a link to the actual poll itself. Here it is, CBS News Poll. It's coming from a website called pollingreport.com, and this website it only publishes real polls that are done by reputable polling organizations. CBS News is a reputable news organization, and so we can pretty safely assume that it's a legitimate poll. It was of a random sample. So we'll just go ahead and say yes. Let's go back to our worksheet here. Okay, so we'll just say yes. In the homework, if it doesn't say one way or another, usually just say yes, just so you can finish the problem. All right, is the sampling distribution normal? We have to check. Is n times p0 greater than 10? Well, the sample size is over 1,000. And so you're almost guaranteed to have at least 10 successes, 10 failures in a sample size that large. But just let's just check anyway. So n times p naught. Well, n is sample size, 1,280, times that by p from the null hypothesis. Now, we use the null hypothesis p of the 0.50 because we're working under the assumption that the null is true. At least for now, we're assuming the null is true. So we'll just write 0.50. Do that calculation. Actually, I don't have to do the calculation. I can see it's 600 and something, actually 640. That's way bigger than 10. So the answer is yes. And n times 1 minus p naught. Well, p naught is 0.5. 1 minus that is also 0.5. So that's also 640. Okay, so yes, the sampling distribution is a normal curve. Okay, so we did that. Let's check it out. Now, calculate the sample proportion. Well, actually, sample proportion's calculated for us, 0.58. So we don't actually have to calculate that. And then the z statistic. So p hat minus p naught, that's 0.58 minus 0.50 divided by square root. P naught is 0.50. Now notice we're using the p from the null hypothesis, not p hat, for this calculation. Again, because we're assuming the null is true for calculation purposes. So 0.50, 1 minus p naught is also 0.50, divided by n, which is 1280. Okay, so let's do this calculation. 0.58 minus 0.50 is 0.08. I don't need a calculator for that one. Okay, now, for the denominator, let's get a calculator out. So let's multiply 0.5 times 0.5 is 0.25 divided by 1280 is 0.00019. Now, occasionally your calculator might give the answer in scientific notation, so don't let that mess you up. Just it's just whatever the number is. Now take the square root. There's a square root button. Okay, 0.013975. Let's not round off too much here. So let's see, you don't need 15 digits here, but at least the calculator keeps disappearing when I write. So 0.013975. Okay, well that's probably good enough for accuracy. Okay, so now take that number and divide it into 0.08. So let's clear this out here. So 0.08 divided by 0.013975 gives us 5.72. All right, I've got to go out of the box here. 5.72. All right, now that is Z. That is a huge Z-score. So normally at this point, you would go to either the Z-score table and you would look that up, or you would go to the website or a calculator or something, and you would enter this in. But because the Z-score is so huge, we know the p-value is going to be virtually 0, which brings us to step 3. So the next page has step 3. Find the p-value. Okay, so it says p-value is the area of a tail. I recommend, especially for z-scores that are smaller than this, I recommend drawing a picture of this. The alternate hypothesis is a greater than here, so that means we're looking at the right tail. So I'm looking at that part of the normal curve, 5.72. All right, except it's 5.72 is 5 standard deviations above the mean, which is actually more like there. So we're just gonna say p-value equals 0 for this. All right, step 4, make your conclusions. Okay, so do we reject the null right here, or do we fail to reject the null? Well, if p-value is small enough, well, p-value certainly is small enough here. The original question said 5% level of significance, which means 0.05. P-value of 0 is way less than 0.05. So we reject. We reject the null. That's the statistician's way of stating the conclusion, but we want to give the conclusion in plain English. And so we can say we rejected the null, so we found evidence that the alternate is true. So I can say this for my final sentence. There is evidence that a majority, so basically whatever the original question was, if you reject the null, then you're saying yes to the question. That there is a majority that supports or that believes same-sex marriage should be legal. That believes same-sex marriage. I'm just going to abbreviate here because I'm running out of room. Saying same-sex marriage should be legal. And that is it for the hypothesis test.